All right, this is Mr. Wyrick, and I'm here to go through the Unit 6 test review with you just real quick. Hopefully we can see all this. Write out the formulas for the area of each figure. The rectangle is length times width. That's an old classic. The triangle is 1/2 of the base times the height, or base times height divided by 2, however that works for you. The circle is pi times the radius squared. The semicircle is pi times the radius squared divided by 2. The trapezoid is going to be 1/2 of base 1 plus base 2. So you average those two bases together, and then you multiply that by the height. And then the regular polygon, you're going to take 1/2 times the apothem times the perimeter. And, you might need to write those in perimeter. Okay. A regular hexagon has an apothem length of 3.56. If each side of the hexagon has a length of 7.32, what is the area of the hexagon? Round to the nearest tenth. This is going to be 1/2 times 3.56 multiplied by that perimeter, which is going to be 7.32 times 6, 2, 1, 18, 19, 42, 43. So times 43.92. I'm not real sure of the answer on that one, but you have access to a calculator where, I'm recording this on what's my calculator today, so not going to get that. A regular heptagon has an apothem length, and each side has a length of 5.7. What's the area? So this is 5.7 times 7. That's 9 and 40. 7 times 5 is 35, plus 4 is 39. So we're going to have 1/2 times 9.2 times 39.9. Again, you could type that in a calculator. You can get the correct answer. Not going to hurt anybody's feelings. Find the area of the composite figure. Here's the thing on this one. Got to do a little work. This is 15 times 30, which is 450 square feet. This in here is going to be, 65 minus 15 is going to be, we take that off, and this part in here is going to be 50. So 50 times 15 is going to give me 750 square feet. And then on this over here, if this is 50 minus 30, then this whole thing is 20, and half of that is going to be 10. So 10 squared is going to be 100 pi square feet. And then I divide that by 2, so that's 50 pi square feet. So putting that whole thing together is 7, 8, 9, 10, 11, 12. So it's 1,200 square feet. And then we've got 50 pi added on to that. I think this question on the test is going to be an actual fill in the blank. So make sure you use the pi button on the calculator to get that decimalized answer. But for the review, that's going to be good enough. Number 5, what is the area of this quadrilateral? Again, I would go right here and kind of use that. I've got a trapezoid then here, and it's 1, 2, 3, 4, 5, 6, 7, 8. Oh, is that through that point? I don't know if that's through that point. Well, this could be interesting. Okay, let's count. This is going to be 11. I don't think that goes through that point. So that's going to be a little difficult to use. Might be able to go. How far is this? Wow. Okay, this is what I'm going to do instead. You get to see me making mistakes and thinking about it in real time. So if I make this a rectangle here, and this is 11, and this is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to start with 88. Okay, and then this one is 3 and 1, 2, 3, 4, 5, 6, 7, 8. So I would do 3 squared plus 8 squared, and then take the square root of that. Or no, I don't need to do that. Oh my goodness gracious. Okay, you really are getting to see me think about this in real time. That's 8 times 3 is 24, and it's a triangle, so half of that is 12. This one's going to be 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, 3. So that's 8 by 3, which is 24. So this is going to be 12. So I'm going to subtract 24 from this. 8, 7, 6, 5, 4, 8, 7, 6. So this is going to be 64 units squared. Sorry that took me so long. That was wild. George is creating an ad that includes a donut as part of the design. Using a compass, he draws a circle that has a radius of 7. So this whole thing here is 7. Using the same center point, he draws another circle that has a radius of 2. So this radius is just 2. So the area of the shaded part of the donut, I'm going to take 7 squared times pi. So that's 49 pi. And then I'm going to take away this middle part. So that's just going to be 2 squared, which is 4 pi. So the area is going to be 45 pi square inches on that one. Don't do the subtracting first. You need to get the area of the big one first, then subtract the area of the small one. You don't want to get 5. 5 would have given you 25, which wouldn't be right. You know, the way circles grow adds a lot of area. And again, if this is one that's asking you to fill in the blank, use the pi button on your calculator. Be smart about how you're doing that. Number 7, what are the properties of a rectangle that set it apart from other parallelograms? It has 4 right angles, and it's also going to have diagonals that are congruent. What are the properties of a rhombus that set it apart from other parallelograms? This one has 4 congruent sides. The diagonals, almost forgot an A in the word diagonals there. The diagonals are going to bisect the angles. And the diagonals are perpendicular. They make 90-degree angles. PQRS is a parallelogram. If P is 45, what is Q? That's 180 minus 45, which is going to give us 135. What must be the value of X to prove trapezoid DEFG is an isosceles trapezoid? I can set either pair of these equal to one another and get the correct answer, and it should solve right. Isosceles trapezoid, you only have to have one pair. And since these are closer together, that's what I'm going to use. 9x minus 3 is equal to 8x plus 9. That way I can subtract 8x, and get x minus 3 is equal to 9. So x is 12. If I put 12 in here, that's 60 plus 15 is 75. If I put 12 here, that's 84 minus 9, which would also be 75. So it still works out. Important to check your answers. How do you determine the interior and exterior angle measures of a regular insided polygon? The sum of the interior is the number of sides minus 2 times 180. And if you want to find an individual angle measure, you just divide that by n, the number of sides. Because it's regular, they'll all be the same. If it's not regular, you can't really do that. The exterior angle measure is always 360 when you add it all together, so you'll just divide that by n, the number of sides. Then the last one, number 12 here, given kite TUVW, find the measure of U. This has 4 sides, n minus 2 times 180, that's 4 minus 2. So 180 times 2 is 360. This is going to have 360 degrees in it when I add them all together. This angle and this angle, because this is a kite, are exactly the same. So that's 360 minus, I'll go ahead and just say 206. So 60 minus 6 is 54. 3 minus 2 is 1. This is 154. And then I've got to subtract this bottom W right here. So I subtract 54, and I'm left with 100. So angle U should be 100 degrees. Hopefully this helps you out on the test.